Hello everybody, welcome back. We're going to be simplifying some square roots today. Now the two things to focus on when simplifying square roots is you want one of the factors of your number to be as large of a perfect square as possible. And you always want even exponents, because when you're taking a square root, you can take the square root of an even exponent but not an odd exponent. Let's start off with number 1 here, 50a squared. To make this work, we need to break down 50, since 50 is not a perfect square. 25 times 2. And notice the a has an even exponent, so we're good. So we can take the square root of 25, we can take the square root of a squared. And then when you take the square root, you put it outside the radical. So the square root of 25 is 5, the square root of a squared is a, and all we're left with is a radical 2. So I'm going to use radical 2 and square root 2 interchangeably. They refer to the same thing. Alright, now look at number 2. 8 isn't a perfect square, but I can break it down into 4 times 2. Now we have a to the third. I'm going to rewrite a to the third as a squared times a. Y squared is an even exponent. We're good there. Z to the fifth, I'm going to break that down into z to the fourth times z. Alright, and here's the things I can take the square root of. 4a squared, y squared, and z to the fourth. And what we get is 2a y z squared. So when you take the square root of each of those underlined items, that's what you get. Inside the radical, we're just left with an a, 2, an a, and a z. And that's our simplified answer there. Now number 3 here, everything is a perfect square. The square root of 9 is 3. The square root of x squared is x, and the square root of y squared is y. So we just have 3xy. So that was pretty straightforward. Let's try 3 more. 4, 5, and 6 here. Look at number 4. 32a to the third, b squared, c to the fourth. Let's rewrite 32 as 16 times 2. Rewrite a to the third as a squared times a. And then I have b squared c to the fourth. I can take the square root of the 16, the a squared, the b squared, and the c to the fourth. The square root of 16 is 4. The square root of a squared is a. The square root of b squared is b. The square root of c to the fourth is c squared. And inside the radical sign is everything that you didn't mess with. We didn't mess with the 2. We didn't mess with the a. And that is our answer. Simplified answer. Look at number 5, 75x to the third, y to the third. We have to do something to all 3 items here. Let's break down 75 to 25 times 3. Now see, I could break down 75 into 5 times 15, but neither of those would be perfect squares. 25 times 3 times x squared times x times y squared times y. And then I'm going to underline everything. We can take the square root of. Square root of 25 is 5. X squared, y squared become x and y. And inside the radical, we're left with an x and a y. And there's our simplified term, 5xy square root of xy. Oh, we forgot the 3. Yeah, we need a 3 in there, so the 3 stays put. Alright, number 6, 20x squared, y to the fifth. Okay, let's rewrite 20 as 4 times 5. X squared will be fine. Y to the fifth, we're just, whenever you have an odd exponent, lower it by 1, and then just multiply by an extra variable, whatever it is. The square root of 4 is 2. The square root of x squared is x. The square root of y to the fourth is y squared. And what are we left with? A 5 and a y. Alright, got one more example for everybody here. Number 7, 12x to the third, y to the fourth. Let's rewrite 12 as 4 times 3. Let's rewrite x to the third as x squared times x. And then x to the fourth we'll deal with. Square root of 4, square root of x squared, square root of y to the fourth. We're left with 2xy squared on the outside of the radical, and inside the radical is 3x. Okay, I hope that helps explain simplifying radicals. Thank you for watching.